Hello everyone, this is Viji. Practical data analysis made possible by Pandas. And its two data structure, series and DataFrame. Series look like a one-dimensional Numpy array and DataFrame looks like a two-dimensional array. But there are key differences. Unlike Numpy array, the axis can be labeled in the DataFrame. And the data type of each column can be different in the DataFrame. In fact, DataFrame is the fundamental data structure of data analysis. Let's follow these 5 steps to analyze the data. Let's go to the Spider editor. Import Pandas as PD. Requirement. Most companies decreased in Marketcap this year, but very few companies thrived. Let's find out the top 10 companies that increased in Marketcap from March to August. Data collection. We have downloaded 2 data sets from the company's marketcap.com at 2 different dates. Click the Files tab to see them. March 22 CSV file lists the largest 6,000 publicly traded companies in March. Another CSV file for August. Note that market cap fluctuates based on the shared price. So a few companies are likely replaced by another set of companies in August. Let's convert the CSV file into data frames by applying the read CSV function, one of the most used functions. Run it. Click the Variable Explorer. The 2 newly created data frames are shown here. Next is the Exploratory Data Analysis, also known as EDA. The goal of EDA is to understand the data and document the findings. There are several methods to run EDA. Let's follow these 5 steps. Let's analyze the March data set first. Observe data. Determine the number of rows and number of columns. The shape method returns the dimension of the data frame, 6,000 rows and 4 columns. Let's capture the findings using the print function. Next, let's look at the columns. There are 4 columns: rank, name, market cap, and country. D types list the data types of each column. The info method prints more information including the data types and memory usage. We can find missing values by applying isNA method. It returns true if the data value is NA or none. Everything else gets returned as false. Applying sum on top of isNA function returns the count of missing values in each column. Let's check it. Yes, no missing values found. Data distribution. The first 3 rows can be displayed by using the head function. The last 3 rows by using the tail function. The describe function gives a good picture of the distributions of the data. It generates basic statistics for each column like mean, standard deviation, percentile, etc. The market cap ranges from $14 million to $2.7 trillion. If the scientific notation is confusing, we can convert it to float by using set_option function. Now the values are converted to a float data type with 1 decimal place. Only the numerical columns are displayed. We can list the categorical columns as well by passing include equal to all parameter. This shows 5,997 unique names, meaning 3 names are duplicated. The largest 6,000 companies are spread across 68 countries. Next step is to identify the relationship and locate outliers. Let's start with numerical data. Correlation (CORR) method computes pairwise correlation of columns, excluding null values, and returns correlation matrix. Negative 0.3 indicates that the market cap reduces as the rank increases. It makes sense. When it comes to relationship, plots are easy to visualize. Let's plot a scatter plot. Even though we have not explicitly included matplotlib, by default, Pandas use matplotlib in the backend to plot. Let's run it. Click Plots. The plot is as expected. The market cap drops from $2.5 trillion as the rank increases. But most of the companies are below $100 billion. The other plot that we typically use to find outliers is the box plot. We see several points above the whiskers, which are typically reported as outliers. But in this case, it is expected. Moving on to the categorical data, let's begin with the company name. Unique method returns the number of unique values for the name column. Duplicated method marks duplicates as true except for the first occurrence. We can select those duplicated rows by adding a condition. Let's run it. It displays only the last occurrences. We can use the LOC function to select all rows that have Chener energy and display rank and name columns. The index 517 was the first occurrence. LOC is label or name based, whereas ILOC is integer index based. We have to specify rows and columns by their integer index instead of the names. We can also use the query function to display all duplicates. Let's click the new data frame to see the complete list of duplicates. Capture the findings. The next category is the country. We are going to use the group by function to group by countries and count company names and sort them in the descending order. This returns a one-dimensional series. We can export the series to an Excel file by using toExcel function. Let's open the Files tab, run it. It generates country's Excel file. Let's open it. 3,000 plus companies are in US, followed by India, Japan, etc. Let's close it. Note it down. This completes EDA for the March dataset. We should repeat the same for the August dataset. There are 2 duplicates found in the August dataset. Finally, let's summarize the key findings. This completes the exploratory data analysis. The next one is data wrangling or data munching. It is the process of converting the raw data into a more useful form. There are 3 steps here: data cleaning, data merging, and data manipulation. Data cleaning is about fixing the anomalies in the data. When a column is an object data type, it can store a mix of strings, integers, and floats. So it is better to convert them to a string data type to avoid issues later. Let's check the data type. The 2 columns are converted now to a string data type. The next step is to remove the duplicates. This keeps the first appearance and removes the duplicates in the column name. 6,000 rows are reduced to 5,997 rows. Follow the same steps for August dataset. The column names are almost the same for both datasets. Let's rename them to avoid issues during merging. This completes the data cleaning process. Next up is the data merging. Merge the March and August dataset by performing the outer join method, keeping the name and the country common between the dataset. It results in a data frame with 6,650 rows. This means a few companies are replaced in the top 6,000 list between March and August. Let's use isNA and sum method to determine the count of those companies. 653 null values means 653 companies made to the top 6,000 list in August. And 652 companies dropped from the list during that period. Let's review the merged dataset to see what's going on. How come Meta is not in the August list? This is not right. Let's scroll down. We see Meta but with a slight change in the name. Let's go to the data cleaning process and use the replace function to fix the Meta name in the August dataset. Once the name is replaced, the number of rows reduced to 6,549. There are several methods to fix the null values. One method is fill_NA. Let's fill the missing values in the March market cap with the August market cap data. Let's check. Now there are no null values found in the March market cap column. Clearly, this is not the right approach to fix the data. I just performed it anyway to show the functionality of the fill_NA method. But in real scenario, the data sets will be transferred back to the data cleaning step. Each null item will be reviewed in detail and decided accordingly. For this exercise, let's drop all the rows that have null values. The number of rows is now reduced to 5,346. Finally, data manipulation. It is about applying logic and calculation to generate a completely different set of data. Let's calculate the delta market cap in millions by subtracting the August market cap with the March market cap and then divide it by 1 million. Sort values in descending order. The setIndex function converts a column to an index label. Before running it, let's look at the data frame. The index are integers. After running, the index numbers are replaced by company names. We can also drop columns that are not needed. This completes data manipulation. Now let's display the results. We are interested in the top 10 companies, so we'll drop the remaining rows. Print the results. Let's restart the kernel. Quickly browsing the code, we notice a typo error. Let's correct it as no missing values found. Run it. Undock the console. Here is the summary of the complete data analysis. It starts with a clearly defined requirement, then exploratory data analysis for March dataset and for August dataset. The key findings of the exploratory data analysis are summarized here. Finally, the result. The top 10 companies that increased in market cap between March 22 and August 22. This completes our data analysis. Let's look at few more commonly used functions. The where function returns null values where the condition is false. Apply a short-term lambda function along market cap delta column to generate a new column based on the if-else condition. The companies that increased in more than $25 billion in market cap are marked as yes. Sample function returns 3 random samples from the DataFrame merge. Finally, time series. Data range functions return 6 dates at a monthly frequency starting March 2022. Changing the parameter from M to H returns at an hourly frequency. Finally, the Pandas cheat sheet. It is helpful and it is from pandas.pydata.org. The links to download the cheat sheet, dataset and the code are available in the description. Enjoy the coding. Thank you. With Pandas, data wrangling or data munching is this easy. Learning is fun.